Hello, this is Daniel, and welcome to another AutoFlex Connect settings tutorial video. Today I will be looking at one of the vent grid modifiers. Vent grid modifiers allow you to alter your vent grid operation, kind of like secondary modifiers allow you to modify staged equipment operation. The vent grid modifiers are secondary modifiers that can override the normal vent grid operation in specific ways during specific situations. Today I am going to be talking about a modifier that makes use of an outdoor temperature probe, and then specifically it is the low outdoor temperature bandwidth modifier. It's a big mouthful, but basically it just means that you are measuring the outdoor temperature and you are decreasing the amount of ventilation that you are doing if that temperature outside is really cold, because the air is going to be much more effective at cooling when it is so much colder. That is the general idea of the modifier. I'm now going to hop into the settings and explain what the different settings are for, and then I'll give a few examples to try and simplify things and try and help you understand how changing the different settings affects how the vent grid is operating. So let's go ahead and hop into our vent grid here, and then we'll go to the modifiers menu down at the bottom. So here we have our outdoor temperature probe modifier. I will select my outdoor temp as my sensor. And then the low outdoor temperature bandwidth modifier. Once I hit on, then I see I have a range from and to and a factor that can be all the way from 1 up to 2. Now the range, this is the temperature through which this modifier is going to be active. So right now I have it from 50 degrees down to 25 degrees. It is going to be active. At 50 degrees, the factor, it's just going to start affecting it. It's kind of like a variable fan, how it ramps up. So at 50 degrees is when it only starts affecting it, and then at 25 degrees or lower, then it's going to be at the full factor of 2. If you're somewhere in the middle, let's say about halfway between 50 and 25, then our factor is going to be somewhere in the middle between 1 and 2, so it'll be at about 1.5. I will explain a little bit later exactly what this factor is. That's the real setting that is going to change how your vent grid operates. So for now, I'm going to keep it at a factor of 2 because that is the easiest to explain. And we'll go through some examples, explain how a factor of 2 affects things, and then I will take a look at a factor of 1.5. So first off, let's just save that. We've got our factor of 2. So let's go back to our main menu. You can see currently it is 72 degrees and we're at 20%, which was the expected output. So I'm going to manually override my outdoor temperature down below 25 degrees. So we are going to be at our maximum factor. So we're going to be at a full 2.0 factor. And we will see here our displayed temperature changes from 72 down to 71 degrees. And our percentage of output changed from 20% down to 10%. And we're also now purple, showing that a secondary modifier is affecting it. So let's hop in here and I can show you what's going on. So let me pull out here. This is what our steps are actually calculated at right now. This is the adjusted table, how it's coming up with the ventilation rate for the temperature. So because we have a factor of 2.0, a bandwidth factor of 2.0, we are doubling our bandwidth. And remember, the bandwidth for this table, we've got a start temperature of 70 degrees and a bandwidth of 10, which means we have a table going from 70 to 80 degrees. Having a factor of 2 doubles our bandwidth, which means that rather than going from 70 to 80, we are actually now, our table is going from 70 to 90. It's now 20, a bandwidth of 20, twice as much, which means each step is twice as big. So rather than being a 2-degree step, it's a 4-degree step. And so because we've doubled that bandwidth, we've increased the temperature range over which our table works. That means that the same temperature is going to be a lower percentage of ventilation. Again, we're ventilating less because the air that we're ventilating with is going to be much more effective at cooling because it's much colder. So if we take a look here, the actual temperature is 72, which is normally 20%. But on our adjusted table, if we take a look, 72 is, rather than being at the top, the maximum for our step number 1, 72 is now in the middle of our step number 1. And so we can see the middle of our step number 1 is going to be halfway between 0 and 20%, which is going to be 10%. So that is why we dropped from the 20% output when it was not modified to 10% output when we activated that bandwidth modifier. So it doesn't update the table here. I just created this table to show you what the table looks like that it's going off. Rather than changing the table, it adjusts the temperature that we display here, right? So it's showing you the adjusted temperature is 71%. And if we would go back to the home page, we can see our adjusted output is 10%. This works across the entire table. So if I bring in this other example here, so with a factor of 2.0, for any given temperature, for our normal table, let's actually hop back in here and then I will bring this up. So for normally, if it's 72 degrees outside, normally we're at 20%. Adjusted, it's down to 10%. If we were at 74 degrees in our barn, then normally it would be an output of 40%. The adjusted is going to be half of that, 20%. Same thing as we go up, 76, 80, and 80, or 76, 78, and 80 degrees are all, they're being cut in half, the ventilation rate. So that is the other way that you can think of this. You can either think of it that the bandwidth is multiplied by the factor. We are going the same, 1 to 100%, but that's being stretched over a larger amount of degrees. Or you can take a look at what the target percent output that it should be. So going back to what we are currently, it's 72, so it should be 20%. And then we divide it by the factor to get our adjusted percent target. So 20% divided in half is going to be 10%. So let me just pull up. I will go to, let's say, so 60-30. So if I change the current room temperature to be 76, then it should be 60%, but because we'll have the modifier active, it'll actually be 30%, and that's going to be right around 73 degrees that it will show as the adjusted room temperature. So let me bump this up to 76. So at 76, give it a moment. There we go. So 76, and then we see the adjusted temperature is 73 and 30%. So if I hop back in and I will bring up this chart again. So I set it to 76, so it should be 60% output. And then our bandwidth modifier comes in. So we have it, which we can see on our chart here. If it was normally supposed to be 60% output, because it's normally 76 degrees, 60% output gets halved down to 30% output. And if we would look on our normal table, 30% output is between 72 and 74. And so the adjusted temperature that corresponds with our normal table, it's pretending like it's actually only 73 degrees to make that output as it should be. So that is a 2.0 factor. I'm going to adjust the factor down to 1.5 and go through the same couple of examples, just looking at it, because it is, to me, it's a little less intuitive, because dividing things by 2 is pretty easy. You just have it, but dividing by 1.5 is a little bit trickier. So I will just show you now at 1.5. Let's make sure that I save that. Then we'll go back here. So we're at, we can stay at 76. And you'll see here, I will bring up a couple other, I've got my other dealios here, charts. All right, so you can see we're at 74 adjusted temperature and 40%. So 76 is on our adjusted chart, 76 is going to be 40%. So that makes sense. On our real chart, or the normal one, just throw these back up. On here, 76 should be 60. So why are we doing 40? Well, if we look here, normal percentage 60 divided by 1.5 equals 40%. So again, we take that normal target percentage of output for the room temperature. So 76 degrees, normal target percentage output is 60. We divide it by the factor of 1.5, and that gives us our adjusted, our bandwidth modifier adjusted output percentage, which is down to 40%. And again, it's displaying the adjusted temperature that goes along with that 40% output that it is currently doing. And as well here, you can just see this is the chart or adjusted the adjusted vent grid to show you multiplying the steps, adjusting the bandwidth by that 1.5. So rather than a 2 degree step, our bandwidth has increased by 1.5. So it's a 1.5 times 2 is 3. So rather than a 2 degree step for all of them, we've got a 3 degree step. And so that's what this is, the modifier adjusted table that it would be working on when the modifier is fully active. So that is what it looks like for a factor of 1.5. And I will just show you now one final thing is, again, if I go back and I adjust, so I'm somewhere in the middle of our settings, right? Because we said from 50 degrees down to 25. So as I said, if we went let's see, I want to go about 12, so 25, 37 is going to be about halfway. So now we're going to be at about 1.25 factor, because my temperature is about halfway in between that 50 degrees and the 25 degrees that I set up as the range over which my modifier is active. So because the temperature went up, I am going to expect my adjusted temperature to go up a little bit and my adjusted ventilation rate to go up a little bit. And there you can see up to 74.8 and 48% ventilation. And that makes sense. We said, hey, the outdoor air is a little bit warmer. And so it said we need to work a little bit harder and push through more air because it's not going to be cooling things down quite as much as that 25 degree air. So I hope these examples and these charts have helped to clarify how these settings work, how the factor number adjusts your grid, how it expands it, and basically lowers the amount of ventilation that you're doing when your air that you're ventilating with is much colder and thus much more effective. If you're still confused or if you have more questions, feel free to leave a comment down below, and I will do my best to help you out and clarify things, or possibly to make a follow-up video to clarify. But for now, that's going to be it for this video, and I will see you guys in the next one.